Welcome, dear learner. We are discussing about the physical techniques for synthesis of a nanomaterial. In this lecture, we have to see what is the pulse laser deposition. So, in previous lecture, we discussed the physical vapor deposition. In that, first is a thermal evaporation, in which the heat energy is used to evaporate the target material. And this evaporated material or the vapor is deposited on the substrate. And second technique is a sputtering technique. Next physical techniques for synthesis of a nanomaterial is ball milling method. Friends, in this lecture we have to see what is the pulse laser deposition, advantages of a pulse laser deposition, disadvantages of a pulse laser deposition. Now, after attending this lecture, the student will be understand about pulse laser deposition, its advantages and its disadvantages. Pulse laser deposition, this is the physical vapor deposition. This is a physical method for synthesis of a nanomaterial. In this method, vaporization of material is done by using pulse of a high power laser beam. That is, the laser beam, high power laser beam is incident on the target material, and so that the material is evaporated, and this evaporated or vapor or atoms, or simply say we say that per laser plumb is deposited on the glass substrate. The setup consists of a ultra high vacuum or high vacuum system equipped with inert or reactive gas uh, introduction facility. Here, the inert gas, we can introduce the inert gas inside the vacuum chamber. Okay, and the vacuum is ultra high vacuum. Generally, we can use the argon gas. Okay, laser beam is an incident on a glass on a target material through the quartz window. Okay, now when the laser beam is incident on the target material, okay, laser plumb is a form, and this plumb consists of the atoms. Okay, these atoms are deposited on a glass substrate so that we get the thin film. Okay, here the target material can be rotated, and the sample or the substrate is placed on heatable sample stage. This method, in this method, the high power pulse laser beam focus on a target that is inside the vacuum chamber. The target material is vaporized by laser beam in a form of plasma plumb and deposited on a substrate as a thin film. Okay, we can say that plasma plumb or laser plumb. Okay, the high power laser is an incident on the target material so that the laser plumb or plasma pulp is a form, and this is deposited on a glass substrate at a different temperature. We can change the temperature of a substrate by heating plate. Okay, usually laser operating in a ultraviolet region, okay, such as excimer, that is excited monomer. The laser wavelength is in ultraviolet region. It is not in infrared region or it is in a visible light. We generally use laser beam in ultraviolet region, and wavelength of commonly used excimer's lasers are here. Wavelength is in nanometer. F2 it is 157, ARF it is 193, KRCL it is 222, then KRF 249, XECL 308, XCF is 350. We know that the ultraviolet range is below the wavelength 300 nanometer. Okay, 300 nanometer. Visible light having wavelength greater than 300 nanometer, and it is up to the 750 nanometer or simply 800 nanometer. Beam above 800 nanometer there is a infrared. Here the laser operating is in ultraviolet region. When a laser pulse is absorbed by a target, its energy first converted into the electron. Excitation and thermally, chemically and mechanically resulting in vaporization, ablation, plasma formation and exfoliation of a target material. The laser pulse is an incident on the target material, and there is a excitation of an electron, and it is thermally, chemically, mechanically and resulting in vaporization of that target material, vaporization, ablation, plasma formation and exfoliation of a target material. A powerful beam of a laser evaporates the atom from a solid source, and atom collides with inert gas atom. Here the evaporated atoms collides with inert gas atom and cool on them, forming cluster. Cluster is a group of the particle. They condense on the colded substrate. The method is often known as laser ablation. That is, when laser beam is incident on a target material, it evaporates the atom, and these atoms are collides on inert gas. Okay, and this there is a formation of a cluster, and this cluster is condensed on substrate, so that we get thin film, or thin film is for gas pressure is very critical in determining the particle size and distribution. Particle size, that is deposited on a thin film, and distribution of a particle, here the vapor pressure play very important role. Simultaneous evaporation of another material and mixing the two evaporated material in inert gas lead to formation of alloy or compound, so that evaporated material which consists of the atoms, okay, and these atoms can be combined with the inert gas, and there is a formation of alloys or its compound. This method can be produce some novel phase of the material which are not normally formed. For example, single wall carbon nanotubes are mostly synthesized by using this method. So this method is used to produce single wall carbon nanotubes. Okay, so this is a very some novel phase which is produced by using this pulse laser deposition technique. Now this method have some advantages over the other synthesis method. It is able to preserve stoichiometric ratio of the target material. Okay, the stoichiometric ratio is preserved by using this method. The deposition rate is relatively high. Okay, that is when the laser beam is an incident on the target material, the atoms are instantaneously emitted. Formation of a plasma plum, and this plasma is deposited on the glass substrate, and this deposition rate is relatively high, and the thickness of the deposition film can be controlled simultaneously with the deposition process only by turning the laser on and off. Okay, here the thin film thickness of the thin film can be controlled by simultaneously with deposition process. Okay, by turning a laser on off. Okay, so we can control the thickness of a thin film. Okay, this is also one of the advantage of this synthesis method. The fact that laser is used as an external agent's energy source result in a very clean process without heat filaments. We does not use heat filaments. So this process is a very clean process. This method can be produced some novel phase of the material which are not normally formed. For example, again single wall carbon nanotubes can be synthesized by using this method. So this method preserve stoichiometric ratio, deposition rate is very high. Okay, thickness of the thin film can be controlled by turning laser on and off. Okay, here in this process we use a laser so that this is a clean process. Okay, and this method is used to produce carbon single wall carbon nanotubes. Now good adhesion between coating and a substrate. Okay, there is a very strong adhesive force between the this target material and the substrate, and therefore there is a good adhesion between the coating and a substrate. The coating at a room temperature, we can change the temperature, okay, by using heating plate. Okay, but the formation of thin film can be possible at a room temperature also. There are some disadvantage of this method. Splashing of a micron size particulates, then small area uniformity. It is about 1 centimeter square. Okay, there is a very small area on which the deposited film is uniform. Then non conformal coverage, then extremely complex models. This models is extremely complex. Okay, so these are the disadvantages of this method. Now in this lecture we discuss when the laser beam is incident on a target material. This laser beam is absorbed, okay, and formation of plasma plum or laser plum. It's ablation, okay, and plasma formation. Okay, so this when the laser is incident on the target material or surface, its ablation and plasma formation. Then plasma dynamics, that is the atoms or the plasma is going toward the target, the substrate, okay, which is in vacuum, okay. We use ultra high vacuum system, okay. Here the vacuum is very important, okay, and the plasma dynamics, that is plasma going to the substrate and deposited on a substrate material, deposition of a material separated from the target on substrate, that is the sputtering and the condensation. Then nucleation and growth of a thin film on the substrate surface, that is which here nucleation means there is a deposition of the atoms on a substrate, okay, which factor affect the deposition, okay, that is a thickness, okay, distribution of a particle along the surface. The factor affecting on the deposition is laser parameters, surface temperature of a substrate, substrate surface, okay. If the substrate surface is slightly rough, then there is a very good adhesion, okay. And background pressure, that is pressure, okay, or vacuum, okay. These factors are very important while deposition of a thin film. Friends, now you have some assignment. First question is explain pulse laser deposition in detail. Second question, state advantages and disadvantages of a pulse laser deposition. What is plasma plum? What is laser ablation? These are the four questions. Now you have to write the answer of this question and send this assignment on Google Classroom. In next lecture, we have to see what is ion beam deposition. Thank you.